Hi, for this recording, I'm going to show you how to determine if the infinite series summation of n power 4 minus 1 over n power 5 plus 1 n power 4 plus 2 converge or diverge. Now, for this particular problem, I'm going to use a test called the limit comparison test. The statement of limit comparison test can be found in David Brandon text page 99, which says that suppose sum of an and sum of bn have positive terms, the series an and series bn have positive terms, and that an over bn converges to L as n approaches infinity and L is a number non-equal to 0. Then, if the series bn is convergent, then the series an is also convergent. If a series bn is divergent, then the series an is also divergent. Okay, basically, it means that the series will converge or diverge together if an over bn approaches to L, and where L not equal to 0, and both an and bn are series positive terms. Now, for this, we also have to know a little bit of what are the basic series. So on page 102, there are some basic series. You want to take note in particular. Summation of 1 over np, for p greater than 2, equal to 2 is convergent. And for p less than or equal to 1, in particular, this series is divergent. In particular, for p equal to 1, summation of 1 over n, which is 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 and so on, is divergent. And we also have a name for this series. We call this the harmonic series. Now let's go back to the original problem now. For this problem, I'm going to use a limit comparison test. So I say an is equal to n power 4 minus 1, n power 5 plus 7, n power 4 plus 2. Now the question is, how do we come up with bn? Compare with what? So make them as simple as possible. So I copy down an, and then I start to throw away small term. What are the small terms? So I can throw away the 1, because 1 is nothing compared to n power 4. So I can throw away the 1 and throw away the 2. And then I compare n power 5 and 7 to n power 4. I know n power 4 is much less than n power 5 when n becomes large. So I can throw away this 7 n power 4. So eventually, I can say that bn behave like what? Like n, or I should say an behave like bn. Well, what is an now? Behave like n power 4 over n power 5, which is 1 over n. So an behave like 1 over n. So I'm going to let bn equal to 1 over n. Okay, so now I'm going to compare the ratio now an over bn. So an over bn. So what is an? An is n power 4 minus 1 over n power 5 minus 7 n power 4 minus 2. Alright, plus 2 plus 7 n power 4 plus 2 is an, and divide by bn. Now divided by bn is 1 over n now, since I say bn is 1 over n. This is 7 multiplied by n, so you get n power 5 minus 1 over n power 5 plus 7 n power 4 plus 2. Now divide by the dominant term, you get 1 over 1 minus n power 5, 1 over n power 5, 1 plus 7 over n plus 2 over n power 5. When you divide both denominator and numerator by n power 5. And we know that at n approach infinity, where does it go to? It goes to 1 minus 0, 1 plus 0 plus 0, which is 1. So in this case, an over bn approaches 1, and this number is L. I know that L is not equal to 0 now. And we also know that an and bn are both have positive terms. So First, I should write this down where an, bn are both positive. We need this in order to apply the limit comparison test. So I take the ratio, I find that this an and bn approach to 1, and 1 certainly is not equal to 0. And so, conclusion. My conclusion is summation of an, which is n power 4 minus 1, n power 5 plus 7 n power 4 plus 2, n from 1 to infinity, and summation of n from 1 to infinity, 1 over bn is 1 over n, converge or diverge together. However, we know also just now on page 102 that this series summation of 1 over n is a divergent series. We call it harmonic series. It's a basic, it's divergent series. Therefore, we conclude now by limit comparison test. We conclude now summation the series of n4 minus 1 over n power 5 plus 7 n power 4 plus 2 diverge. So let's recap again what law I'm using here. I'm using the limit comparison test, which require both series have positive term and limit of an over bn converge to L where L not equal to 0. And the conclusion is both series will converge or diverge together. I also know how do I get compare with what series. So there are some basic series to compare. And how do you come up with bn here? I strike out small term and eventually get the bn out and compare. Bn must be a series. The sum of the series bn must be a series where you know the behavior, whether it's converge or diverge. So that is the end of this recording.